Hi, I'm going to discuss KTU subject Group A Mathematics 2. That's for S2 Computer Science students. It's called Group A Mathematics 201. I'm going to discuss this subject, and uh, I'm starting with the module 3 here. Okay, in that in this video I will cover only this concept, that is vector length and unit vector. Okay, a vector, we all know what is a vector. A vector has got both the magnitude and direction. Okay, so I'm directly jumping into the length of a vector. Okay, length or norm of a vector v. V is here defined as n dimensional, like v1 v2 up to vn. Okay, then the length of v is denoted like this. Length of v is square root of v1 square plus v2 square plus up to vn square. This is the formula for length of the vector. Okay, now if the length is 1, that is length of v equal to 1, then the vector v is called a unit vector. Okay, this is the basic concept of vector length and unit vector. Okay, so let's go through one or two examples here. Let's say v equal to here minus 1 2 0 minus 2 0 4, defined in r raised to 6, that's 6 elements. So find the length of v. Okay, we have a formula, length of v equal to square root of this square plus this square plus this plus this square plus this square plus this square. Okay, by computing all this and summing together we get root 25, which is equal to 5. Okay, this is the first problem is over. Now second problem, let's say v equal to 3 minus 2, and it belongs to R2 space. So the length of v is square root of 3 square is 9 minus 2 square is 4, 9 plus 4 root 30. Okay, this problem is solved. Okay, okay, here third problem, b is defined as 1 by root 15 minus 2 by root 15 minus 3 by root 15 and minus 1 by root 15, which belongs to r raised to 4. So we have to check whether this v is a unit vector or not. So for that we have to calculate the length of v by using the previous formula, which is equal to square root of this square plus this square plus this square plus this square. When we compute this, we get root 15 by 15, which is equal to 1. So when length of a vector is 1, then that vector v is called a unit vector. Okay, so we have shown that v is a unit vector. Okay, now two or three theorems in this are: the length of v will be always greater than or equal to 0. Length cannot be negative. So here length of v is always defined as greater than or equal to 0. As we know, its formula is square root of v1 square plus v2 square plus v3 square plus up to vn square. This is the formula. For any value of v1 v2 v3, this number will be positive. Okay, this number will be positive, and square root can have both values. We will take only absolute value of it. So the length of v is always defined as greater than or equal to 0. Okay, that's the first property. Then second property is absolute, the length of a scalar multiple of v can be written as absolute value of c into length of v. So this way, length of cv can be written as absolute value of c into length of v. So where c is a scalar. This is the second property. Then third one is, how can we get a unit vector from a given vector? So consider a vector v is represented in n dimensional r raised to n. Then the unit vector of v is defined as u equal to v divided by length of v. Okay, this is how the unit vector is defined in the direction of v. Okay, this is the unit vector u in the direction of v. So u equal to v by length of v. This is a unit vector of v in the direction of v. Okay, now if we need to calculate a unit vector in the opposite direction of v, that's called minus u. Minus u equal to minus v by length of v. So a unit vector in the opposite direction of v can be written as minus u equal to minus v by length v. Okay, this way we can write the unit vector in the opposite direction of v. So if a vector is given, then to calculate its unit vector, divide that vector with the length of that vector. So we can see one or two examples here. Okay, the first question is, find a unit vector in the direction and opposite direction of where v is minus 1 comma 2. Okay, so u can be written as v divided by length of v. We know how to calculate length of v, which is square root of minus 1 square plus minus 2 square. So, and the given vector v is written as shown. So we get the value of u as minus 1 by root 5 and minus 2 by root 5. Okay, now this is the unit vector in the direction of v. Now we need to calculate the opposite direction, so which we take as minus u, which is equal to 1 by root 5 comma 2 by root 5. That is opposite direction of v. That's a unit vector in the opposite direction of v. Okay, so that's the examples. And now I'm going to discuss dot product here. Okay, dot product and angle between two vectors. I'll be very quick. So here let's consider two vectors, u equal to u1 u2 and v equal to v1 v2. This be two vectors. So this is u, this is v. The length of this vector is length u here shown. This is length v. Then this dotted line connecting u and v will be u minus v. Okay, the distance will be modulus of u minus v. Okay, that's the length of u minus v. How we get this? When we draw a vector, this is u, this is v. Then if we draw a vector like this can be this plus this, we get this. So let's say this is x, v plus x equal to u. So x equal to u minus v. So we can write this side as u minus v and apply law of cosine here. Law of cosine is law in triangle. So this is angle theta. These two sides are given. Then opposite side is u minus v. Then u minus v square will be equal to u square plus v square minus 2uv cos theta. This is the law of cosine. Now calculate u minus v. U minus v is u1 minus v1 and u2 minus v2. This is the u minus v. Okay, and apply uh, distance, calculate the length and squared value here, and which is equal to u square plus v square minus 2u v cos theta. Okay, now what's the value of length of u minus v1, u2 minus v2? So this can be written as u1 minus v1 square plus u2 minus v2 square. How we get uh, this thing, this to this? Okay, we know the formula to calculate u1 u2. Suppose u1 u2 is a vector, then this will be equal to square root of u1 square plus u2 square. So when we take square here, we need to remove the square root, so it will be u1 square plus u2 square. Similarly, instead of u1 we have here u1 minus v1, instead of u2 we have u2 minus v2. So we can write from this to this as u1 minus v1 square plus u2 minus v2 square. So similarly, this can be written as u1 square plus u2 square, this can be written as v1 square plus v2 square, this is written as same. So we can cancel u1 square here and u1 square here. v1 square can be cancelled, u2 square and v2 square can be cancelled. So by rearranging, we can write cos theta equal to u1 v1 plus u2 v2 by length u into length v. This term u1 v1 plus u2 v2 is written as u dot v. This is how dot product is defined. So a dot product of two vectors u comma v is u dot v, which is equal to u1 v1 plus u2 v2. This is for two-dimensional vectors. Now consider a generalized case. For that, u equal to u1 u2 up to un and v equal to v1 v2 up to vn. So u dot v is u1 v1 plus u2 v2 plus up to un vn. So this is how dot product is defined. So the properties of dot products are these five. So u dot v equal to v dot u, then u dot v plus w can be written as u dot v plus u dot w. Then a scalar multiple of u dot v can be written as c u dot v plus, which is also equal to u dot cv. This is another property. Then v dot v, same vector dot product can be written as length of v whole square, which will be greater than 0. Consider an example. Let's say v equal to v1 v2. Then what is the length of v, which is equal to square root of v1 square plus v2 square. So here what length v square, so length v square will be equal to v1 square plus v2 square. So this will be always greater than or equal to 0, because v1 square is always positive or 0, v2 square is always positive or 0. So v1 square plus v2 square will be always greater than or equal to 0. So this is important property v dot v, that same vector dot product will be equal to length of v square, which is always greater than or equal to 0. Then v dot v equal to 0 if and only if v equal to 0. Otherwise this scalar product will not be 0. Okay, only for v equal to 0 this expression becomes 0. Okay, these are the 5 properties. Okay, now consider this problem. Here u dot u is given as 38, u dot v is given as -3, and v dot v is given as 79. Okay, 79. Then we need to calculate u plus 2v in dot 3u plus v. Okay, by expanding u plus 2v into dot 3u plus v. So by expanding we get 3u dot u plus u dot v plus 6v dot u plus 2v dot v. So here u dot u we know 38, so 3 into 38, u dot v is -3, then 6 into v dot u and u dot v are same, that's why we can take -3 here. So 6 into -3 plus 2 into v dot v, v dot v is given as 79. By calculating this we get 251. Okay, this is the answer. Now another important theorem is uh, Cauchy-Schwarz inequality. Okay, this is also derived from this dot product uh, derivation. That is, consider uv are two vectors in n dimension, then absolute value of dot product of u and v will be always less than or equal to length of u into length of v. This inequality is called Cauchy-Schwarz inequality. Okay, we may in exam there may be questions to verify whether u and v uh, uh, obey this Cauchy-Schwarz inequality. Okay, so we need to calculate length of u, length of v, then u dot v, then take absolute value, then check whether u dot v absolute value is less than length of u into length of v. Then if this is true, we have verified Cauchy-Schwarz inequality for two vectors. Okay, this is the whole thing I have discussed here. So I have discussed unit vector and the length of a vector, then dot product, angle between two vectors, and then the properties of dot product and Cauchy-Schwarz inequality. Okay, thank you for listening to this video. You can ask your concerns or questions in comment box so that I can reply, or I can produce a new video for correction. Okay, thank you for listening to this video. I hope you got an idea regarding these topics. Okay, thank you.